Jason, will you shut the door? Oh, wait, we'll just wait for Cooper, yeah. Cooper, will you shut the door? Let's go ahead and get started. I promise your group will get to a 5 out of 5 as long as they don't have to talk louder than this. I want to do 2 math top problems. And then we have a couple things to do in the notes, and then it's just your time to work. As a reminder, your Math Club's worksheet, have you finished it? It's going in the 30% category. Yesterday you got a 10 problem synthetic division worksheet. You want to finish it, it's going in the 30% category. And then there's a new assignment today. So if you got both those done, you could always start the new assignment. The new assignment's probably going to be the fastest. I don't know. The synthetic division is pretty fast. Okay, I want to do number 6 and number 7. I totally understand why you weren't working on number 6, because you saw x to the 4th minus 6x squared minus 16, and you said, oh crap, I don't know how to do that, so I'm going to stop. Understood. Why can I not use grouping on this problem? Get a point. It's only 3 times. So I can't use grouping. I'm supposed to just factor and be a genius, and I'm sorry, but I'm not. So instead, what we're going to do to make this into a problem we can handle, I see a lot of x squared. I'm going to say everywhere I see an x squared, I'm going to put a y. So y is going to equal x squared. So instead of having x to the 4th, I'm going to have y squared. Instead of having x squared, I'm going to have a y. So I'm turning my problem from the gray with x's to the pink with all y's. Everywhere I saw an x squared, I replaced it with a y. Are there any questions about the pink?
Why is it not y to the 3?
Because y is x squared. So we had x squared squared, isn't that how we got x to the 4th? So isn't x squared y? So isn't it just y squared? Okay. That's a good question. Why is this an easy factor? Tell me more specifically. Because what? Because the leading coefficient is 1. 2, I heard it best from you, so I'm going to give it to you. The leading coefficient is 1, so it's supposed to be an easy factor. It's a y something and a y something. Don't have to guess and say, you don't have to think much through, let's just be easy. What 2 numbers should I use? Yes. So negative 8 plus 2 is negative 6. Negative 8 times 2 is negative 16. So Elliot's right. It's negative 8 and positive 2. I want to circle that and say I'm done. Why can I not do that? Well, it didn't say I had to solve. Why am I not done? Well, then, if we FOIL it back out, then we've undone our factoring. So what was the point? Tell me about our original problem. Had x's in it, and now we've got y's in it. So we need to go back to having x's in it. So how can I finish it out and get to my final answer? What do I need to change it to? Say it, Paige. Uh-huh. Perfect, and now we're done. Nick, get a point as well, because you're the one who recognized the issue. So our problem was given in terms of x's. You and I changed it to y so we could understand it. But now that we've understood it, and we factored it, we've got to go back to having x's. Are there any questions about number 6? So that's a really useful trick that I honestly kind of blinked on this morning and had to Google it because it happens to the best of us. It's a really useful trick to think through, hey, I don't know how to factor stuff as x to the 4th, but I do know how to factor stuff as x squared. Is there some way I can turn this problem into an x squared problem, something I know how to factor, and then go back to this crazy thing? Okay, on number 7, what should I do first? Yeah, which is a, okay, get a point. If I pull out a 2, I'm left with x to the third plus x squared minus x minus 1. We can keep going. What should we use to keep going? How many terms are there inside the parentheses? Yes, you can have a point. Yes, Ellie said it first, but yes, there are 4 terms inside. 1, 2, 3, 4. So I can use grouping. I'm going to group x to the third and x squared together. I'm going to group negative x and negative 1 together. We're going to group. I'm going to leave that 2 alone, leave them on the outside. What can I factor out of x to the third x squared? X to the second, yes. 4 and 5 get a point. So I'm left with, yes, you have another point, Ellie. My gosh. You're going to be like Arturo last period. He was racking up all the points. Okay, what can I factor out of negative x minus 1? If I factor out a negative 1, Paige, that was good and loud. Let's give it to you. I'm left with x plus 1. Why am I happy? Yes. I understood what you meant, Ellie, because x plus 1 matches the x plus 1, so I'm happy. So I think I'm down to my final answer. I think my final answer is 2 something x plus 1. What's the something? Every group can have a point. Can someone tell me why this is not the final answer? Tell me more about the x squared. She's right. We can keep going with that one. Why? We could just, we're not going to. We're supposed to recognize that. We're supposed to recognize that as the, it is the difference for 5. That's why I need another point. Isn't 1 a perfect square? So isn't this different in perfect squares? This is an easy one. The first different perfect squares we did a few days ago was a 4 and a 25. And Jack said it was 2 and 2 and 5 and 5. That was a harder one. This one's supposed to be a super easy one. It's the easy ones we forget about. Okay, so I can break this down further. So I'm going to leave my 2 alone. I'm going to leave my x plus 1 alone. But somehow I can break that middle one down further. What should it be? Jack's getting another point. So I'm finally at my final answer. Woo. I've completely factored the mess out of it. So, back to the beginning. We pulled out our GCF of 2. We did grouping. We figured out this answer. But we're not completely done factoring because this is the difference of perfect squares. So I can go one more step. And now everybody has been factored. There's no more factoring we can do. It's kind of like when Oprah gave everybody a car. Finally, everybody has what they need. And we can move on. Okay, we're going to save 8, 9, 10, and 12 for tomorrow. We're going to do number 11 now. What's the first thing I should do on number 11?
First, you need to pull out another 3x.
We could, Jax is right, we could send that negative exponent, that negative 5 to the bottom, and that negative 2 with the x to the bottom. I'm not going to because I'm being lazy. I'm going to wait till the very end to punish people. But yeah, that's a genuine good suggestion. Jax, you can have a point for that. The first thing I need to do, you've heard PEMDAS of forever. PEMDAS still applies now. What's the first thing I need to do in this problem? Well, they both have sets of parentheses. That's true, though. Excellent. We got to deal with this, too. So I'm going to leave this first guy alone. Negative 2x squared, y to the negative 5th. I'm not going to mess with him. But I do need to mess with the second guy. Every group can have a point, by the way, for that unanimous exponent. So I need to raise everybody to the second power. 3 to the second power, that's 9. X to the negative what? Yes, because we're going to multiply since we're raising power. Negative 2 times 2 is negative 4. And z to the y to the, yeah. Is it to the 9th? To the 14th. We're raising power, so we multiply our exponent. 7 times 2 is 14. Okay, what's our next step from here? To multiply. So we're going to have negative 18 x to the what power? 2 and negative 4 give you negative 6. Negative 2. We're multiplying, so we add our exponents. We're multiplying, so we add our exponents. 2 minus 4 is negative 2. We're multiplying, so we add our exponents. Negative 5 plus 14 is 9. This is not my final answer. What is my final answer? I heard you, Nick. I heard you. I know table 5 was saying as well, but they got enough points at the moment. We're going to give it to Nick. Okay, so it's negative 18 y to the 9th, and we punish the x squared and send it to the bottom because of that negative exponent. Okay. Are there any questions about our 3 bell ringers? We're going to go to our notes. We are not.
Miss Compton?
Yes, ma'am. Yes, ma'am.
Do you have AJ?
Yes, ma'am.
Please ask him to go see Mr. Ferris in his office.
Yes, ma'am.
Thank you.
Okay. We are not doing long division or synthetic division today. I mean, when I stop rambling, you might want to work on one of those worksheets, but you're not actually talking about that today. That's good news. Look at the next page of our notes. It says practice, so apparently it's something we're already supposed to know. As we discussed before Christmas, we discussed how to add, subtract, and multiply polynomials. Since Christmas, we've talked about how to divide with long division and synthetic. But today, there's this worksheet to help you practice add, subtract, and multiply. But it is a long old worksheet, and you're not going to have to do it all. We're going to say you only have to do the evens. We're going to say you only have to do the evens. Now, we're going to talk through the odds so we're on the same page. You know, the evens and the odds kind of look similar. So number 1 and number 3 are super easy. You just have to pay attention to your sign. Number 1, we would add our like terms. Number 3, we would subtract. I'm positive you can handle one similar to 1 and 3. Number 5 would also be easy, because all we have to do is distribute. Number 7, I think, is easy as well, but you know what? It can't hurt to practice at least one of them. So we're still going to distribute, but they're really wanting us to pay attention to our rules of exponents, so I'm going to go through this one very quickly. 5a squared w the third times a squared w the sixth. That would be 5a to the 2 plus 2 is 4. 3 plus 6 is 9. Minus 5 times 3 is 15. A to the 2, a to the 4, 2 plus 4 is 6. W to the 3, w to the 2, 3 plus 2 is 5. And then last but not least, 5 times 9 is 45. A2, A1, 2 plus 1 is 3. W3, W6, 3 plus 6 is 9. But again, I'm pretty sure you all could have done that, except the one mistake you might make would be on this one. Because you might have forgotten this had an understood 1. So you might not have done 2 plus 1 and gotten a 3. What are we supposed to use on number 9? To get a point. You're supposed to FOIL. Now, again, the whole reason we're practicing this is to make sure we're keeping up with our exponents. First would be 2 times 2, so it's 4. B to the 4th. Outer plus 4b squared, enter, minus 6b squared, and then last, minus 24. Yes, there are like terms. So my final answer is b to the 4th minus 2b squared minus 24. Are there any questions about 7 or 9? $11 is going to be another FOIL. We just have to write it out ourselves. So if you've forgotten, you want to write this out because your 12 is similar, I would actually do my y minus 8 times y minus 8. That's what y minus 8 squared means. And I would FOIL it out and get my answer. 13 is yet again another FOIL. Why are 15, 17, and 19 not FOIL problems? Yes. Yes. I'm gonna guess Paige with this. She's showing her hand. There's more than 2. Yes, we had a binomial 1, 2, and a binomial 1, 2, and that's what we could FOIL. On 15, for instance, we have a binomial 1, 2, but that second guy is 1, 2, 3. He's got 3 terms. It's not a FOIL problem. We're gonna have to distribute. Now 17 we could turn into a FOIL problem. We could FOIL the first 2 guys, and then have to distribute to the third guy. We can make it a FOIL problem. I'm going to do 15 because it's pretty set in stone of how I have to solve it. I have to distribute that x to everybody. So x times x squared, I get x to the third. X times negative 3xy, I get negative 3x squared y. X times 2y squared, I get 2xy squared. Everyone good with the purple? But I'm not done. Why am I not done? We've got to deal with the y. We've got to distribute him as well. So y times x squared will get x squared y. Y times negative 3xy, we get negative 3xy. 1 plus 1 is 2. And last, y times 2y squared is going to be 2y to the third. Are there any questions about the pink? Why am I not done? To get a point. We got some like terms that need to be combined. So x to the third doesn't have a friend. But negative 3x squared y squared goes with who? Do they match? Who matches negative 3x squared y?
It would be x squared y.
It's this, yes. So negative 3 plus 1, we get negative 2 x squared y. Who goes with 2xy squared? Yes, they have the same exponents. 2 minus 3 is negative 1, so negative xy squared. And then this last guy, the y cubed, does not have a match. Now, did you do this last semester? Yes. Has it been a while? Yes. Hence why we're going over a couple of them, and hence why they're practice today. You would say, Ms. Compton, why are we practicing this? Because we actually need to remember how to do this in order to be successful in what we're actually supposed to learn today, which is on the next page. Okay. So if you're good, flip to the next page. So we were supposed to already know this, but this is still kind of complicated. Today's stuff, while you didn't automatically know it, it's not that deep. Probably pretty easy for you. We've got to talk about the degree and the leading coefficient of each polynomial. So a polynomial is x raised to some power. It has to be a positive whole number, like 2, 3, 5, 7. So for a polynomial, we're looking for it's x to some number, and that number better be a pretty number, like 2, 3, 5, 7. So a natural number. So what we're going to go over today only applies to polynomials. So if you're dealing with like a square root of x, or x to the 1/3, this is not going to work. My logic's not going to work necessarily. Okay, we have spent a lot of time talking about a certain kind of polynomial. We spent all of chapter 4 on it. It was like y equals x to the watt power. We spent like half our life on it. Was x the 2, the 3, the 4, the 5, the 6, the 1? What do we spend a ton of time on? A ton of time on. Because we went over them and over and over them. Their graphs look like this. Yeah, but what kind of functions were those? Those were called, what is that graph called? Started with a P. It's called a parabola, and it went with a function that started with a Q. Quadratic, which means we're x to the what power? Quad. Quadratic, it was x squared. We were dealing with x squared for forever. And we talked about y equals x squared. Looks a graph like this. And if I put a negative in front, then it flip it down. And then what if I did y equals 7x squared? What did that do to my graph? The 7. What does the 7 do? It makes me skinny. So we had to recognize stuff about graphs. Just by looking at the given equation, we knew stuff about the graph. So if I gave you y equals negative 1/3, it makes you fat because it's a fraction. Tell me what else. It's going to be down. So I'm going to say flip down because of that negative sign. How did that negative 2 and that 3 make it move? Right 2 up 3. Okay, so seeing that equation, instantly you were supposed to think about how does that make my graph look. That's the same thing we're going to talk about today. Seeing these weirdo looking equations tells us a bit about how these graphs should look. Okay, so you and I figured out it was fat or skinny by looking at the number in front of that x squared, right? Whatever was in front of the x squared told you whether or not it was fat or skinny. In the same way, the leading coefficient is going to tell us if we're fat or skinny. And the leading coefficient is going to tell us if it's negative, whether or not our graph is flipped. So we really need to know that leading coefficient. Because it's going to still tell us, am I fat or am I skinny? What am I? And then have I been flipped up or down? But the only thing is, we're not just dealing with x squared. Type number 1 has x to the 6th, x to the 5th, and x squared. So which one do we pick to look at? Is the leading coefficient the 11, the negative 5, or the 4? And the leading coefficient is always going with the largest exponent. And if you know the largest exponent, you know the degree. So on number 1, what is the degree? What's the largest exponent on number 1? Okay, the largest exponent is 6. And then, so the leading coefficient, the number in front of that x to the 6 is 11. Okay, I'm not going to lie, you know I helped you with that one, so I'll pay attention this time. The degree on number 2 is 7, and the leading coefficient is, okay. One, you're awfully quiet. Would you like a chance at number 3? I'll give you a per thing. Are you at table 1? Okay. Yeah. Okay, thank you. Okay, so it's 7 and negative 21. Perfect. You have 2 points. 3, y'all been quiet. Do you want to do number 4? Okay, cool. Anyone else? How many points y'all got to? How many points y'all got? 5? 4? That's what I thought. 1, you want to handle it again? The degree on number 4? It's 6, the leading coefficient is. And you can have 2 points for that. Okay, and then you're like, great, this is going great. And then you get to number 5 and you're like, uh-oh, They didn't already work it out for me. Oh crap. Okay, before we go there, let's talk a little bit about what that degree means. So yes, the degree goes with the largest exponent, but the degree also tells us about the graph. So the leading coefficient tells us fat or skinny and how our graph's going to look. Is it stretched or whatever? But the basics of the graph itself, we can decide from that from that highest exponent, the degree. So for instance, on number 1, since the degree is 6, if we have a graph, if we graph this on our calculator, it could cross the x-axis up to 6 times. So maybe it ends up looking like 1, 2, 3, 4, 5, 6. Maybe it ends up looking like this weirdo snake. It might. It might not. So the degree tells you, how did I phrase it last time? I phrased it well, and now I'm bringing it blank. Oh yes, the degree tells you how many zeros are possible. So like I said, our degree was 6 on number 1, so our graph crossed the x-axis up to 6 times. It might not touch it at all. It might touch it 4 times. It might touch it 5. But it could touch it up to 6 times. So whatever the degree is, that's telling you how many times it could possibly touch that x-axis. So our degree on number 2 is 7, so our graph could touch the x-axis up to 7 times. Okay, and then we get to 5, 6, 7, and 8. And that's where Miss Compton starts to get a little lazy. Now, clearly, we ought to work this one out, multiply them all. We can get the answer. We can make it happen. But you and I both know that you're going to get this handy dandy calculator. And can't you put that in just as easily as you can put number 3 in with the parentheses and everything? So I'm getting lazy on you. I'm not actually going to work it all the way out. So I'm not going to be able to tell you the leading coefficient. I'm betting it's a 1 because there's a 1 in front of all the x's, but you know what happens when you bet stuff. I'm betting the leading coefficient is a 1 just because there was a 1 here, a 1 here, a 1 here. That's my thoughts. But I for sure know the degree. And let me tell you how I can figure out the degree without actually having to factor all this out. Okay, I know this one is x to the 1. I know when I actually factor this bad boy out, that first term, the highest it's going to be is x to the 3rd. And I know when I factor this last bad boy out, the highest it's going to be is x squared. So if I put all those together, and since I'm multiplying, I add my exponents. 3 plus 2 plus 1, 3, 4, 5, 6, so my degree is 6. So seriously, what I'm doing in my head is I'm adding up all the exponents. So it was 3 plus 2, and there was an understood 1 there. So 3, 4, 5, 6, the degree is 6. So let's look at number 7. It's already on the screen. What do you think is the degree of number 7? It's going to be 3, so you can have it. And the reason it's 3 is because I see I'm eventually doing x to the 2. I'm eventually doing x to the 1. X to the 2 plus x times x to the 1. It's going to be x to the 3rd. So again, I know this is x squared and some other stuff. I know this is x and some other stuff. So x to the 1. I know the highest is going to be is x to the 3. So it's a 3. But seriously, in my mind, I'm just doing 2 plus 1 is 3. I'm betting that leading coefficient is the 2. Just like I'm betting on number 6, the leading coefficient is a 1. And on number 8, what would I guess the leading coefficient is? A 3. Seriously, I'm just looking at what number is already out front, because otherwise 1x, 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 no matter what, you're still just going to have 1x to some number. So no matter what, if there's no number out front, the leading coefficient is probably a 1. Okay, and then I need the degree on number 6 and the degree on number 8. 8's the easier one. It is 10. You can have a point, Nick. The reason it's 10 is because, seriously, 4, 5, 6, 7, 8, 9, 10. Yep, it's 10. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Degree is 10. What is the degree on number 8? 4. 3 and a 1. 3 plus 1 is 4. So am I actually working it out to get it set up the way it was nice in 1, 2, 3, and 4? No. Am I still able to, from these weirdo equations, know a little bit about my graph? Yes. Will we eventually get to the point of graphing it on the graphing calculator? Absolutely. What do you think we're going to be doing tomorrow? This is all leading up to us actually graphing these values. Okay, I'm going to stop rambling here. You have plenty of things to work on. Pick one of the many things. Help on the synthetic division or the long division or the ones from today, please ask. If you want to be like Elliot and you finish the ones from today and want to go ahead and show me to